Okay, so one more video, and then I'm gonna go home. So my dog I can take my dog out. Wife's on a business trip, so I gotta take the dog out. All right, so here we have another one with the 350 megapascals. By the way, this is class 14. This is the third example. I picked out three examples so that one of them would be on the tension side, one would be on the compression side. That's this one, and one would be like kind of overlapping in the tension and compression side. Right? So that was the game plan here. So this one has compression on both sides, 200 here, 250 there, and this one is counterclockwise, so that means it's going that way. Right? And so that's 50. So let's we can find what the center of this is going to be. That's going to be 200. Well, it's going to be negative 200 plus a negative 250 over 2. And we could actually, I don't have to use the calculator because I have the answers over here. Boom. Okay. And so the center is negative 225. Right, so let me plot out these points here. And it looks to me, I actually have the thing right underneath it. I could trace it. So like right there, so we're going to plot these points, and it makes sense to kind of have go by 50s. So there's 50 and 100, 150, 200, and 250 right there, I think. Right? The one underneath it's actually a different plot scale. And then, so here's 50, and here's 50 right there. So we'll plot out this face first, and so it's going to be the 200, right? So there's 100 right there, and here is 200, and then 50, right? So that's going to be clockwise. So that's actually down below here. So he's like right there, and then he's 250. So that's this, and so that should be like right there, right? So you can see that they're going to cross at the 225 or thereabouts, something like that. There you go. All right, and so I can't even make my compass go that small. I'm doing itty bitty, but let's see. We can get one. We can get kind of closer. Is that one? No, let's go with that one. Sorry. All right, that looks pretty good. So we get that one lined up. All right, and then we could actually probably find another one here that could be close to that. It's pretty close. Maybe pencil width could be good enough. Yeah, that's pretty good. And then this one, the center of this should be 225. No, that's the center of that one right there. So we should be, well, first off, let's take a look. We need the R. So I think this one is going to make for a good R right there. So my R, the square root. The leg here, I'm going to take 250 and subtract out the center. See that right there, right? So this, because that's 250, that's 225, so I square that, and then it's just the yield strength. I'm not the yield strength, but the the shear squared. So let's see. Did I get that right? Yeah, look at that. And it's 55.90, and then so we could find sigma A is going to be C plus R. Right, or negative 225 plus 55.90. So we end up getting negative 169.1 megapascals. And sigma B is going to be C minus R, so that's your negative 225, and then the minus 55.90. So it's a negative 280.9 megapascals. And so our tau abs max, remember, is sigma 1 minus sigma 3 over 2, but sigma 1 is equal to 0. So we end up getting 0 minus 280.9 over 2. And so our tau is 140.5. So our maximum shear stress theory safety factor is that 350, well, I should write out the equation, right? Because we haven't seen it. We may take the yield strength divided by 2, and then the tau abs max. And so it's 350 divided by 2 divided by 140.5. And we get that it's 1.25. Great. And by the way, that should be like 140.5, right? It should be there. So this, like right in there, maybe. Yeah. Oh, no. So like right in there. So let's label these A, B, and then right up here somewhere is the tau abs max, which is the important one here. And we made even sigma 1. Like we could have called this one sigma 2, by the way. This could have been sigma 3 instead of B. All right, so let's set this thing up, and we'll go right down the center here. Not going to be great because I just messed. I couldn't even draw a line down the center. I'm getting distracted by the one that's underneath it. That's what it is. Yeah, that's why. Sure. All right, so let's see. There you go. Pencil thickness. I get the 0.5 going. I'm moving to 0.5 right now, so I'm rocking the 0.5. A little bumpy right there. All right, so what did I say? I decided to go 100, 200, 300, and here's your tray 50. 1, 2, 3. Here's your 350 right there. So before we forget, let's come up. There you go. And then 1, 2, 3. Here's your 350. 1, 2, 3. Here's our 350. And we make our nice little diagonals going on here. Happy little diagonals. There's my Bob Ross voice. Oh, messed that up. All right, so now let's plot out our A and B. So that's like 170. 170, but we're over here, right? So here's 100, there's 200, here's 150. There's sort of like we're going to bias it like right there. So there's like our, right around there. So not exactly the center, just a little bit over from the center. And then we have 280 is this other one. So there you go. So here's 200. 250, 300, here's 275, so a little bit over to that side. Right? So trying our best to eyeball it there. Like right there. So let's see where it comes through. Boom. And I like to call this O, and this is A, and this is B. So let's see what is OB is going to be equal to, and I'm going to use my millimeters and try to, here, I'll look at the camera as I try to do this, try to get that just lined up right there. All right, so that looks to me to be like, remember I'm subtracting out this one right here, so I could start like at a point right there. And it looks to me like I almost got 39. That's not what I got before. Huh. No, I got got 44 in there. Huh. Is this not the same problem? 50. Yeah. Okay. Well, that's interesting. And this one, maybe they printed out at a different scale. I think they printed out a different scale over there. That's what. Okay. Making me nervous here. All right. So I want to say that that's going to be 39. Let's see. All right, so OA, that looks like to me that's going to be, of course, this is 30, 32, 31 and a half. We're going half millimeters here. So the maximum shear stress theory, we're going to take this distance divided by that distance, right? So that's the OB over OA. And so we get 39 divided by 31.5. And we get like a 1.238. 1.24. Woo, that's pretty good. Now, if we wanted to confirm this, like when I go a little over the top here, we got our 350 right here. So let's check this thing out. So I'm using the offsets, and I want to go first. I'll go 280.9. He's going to let me do it. I think I got it. Yeah, I think so. All right, so that 280.9 should be offset down that way, right there. Okay. And then do another offset, but here it should be the 169.1. Boom. Okay. And I'm going to use this little command. I like the little chamfer thing, so I just get rid of that. There you go. Boom. And so now we're going to take a line, and we're going to go from the center here down to there, and then we're going to extend it. Boom. Now let's take the overall dimension. There's that overall dimension, and then we will take this other dimension right there to right there. All right. And so let's find out what that is. We have 408.53, call it, and 327.87. Boom! Check it out. We got 1.246. Ergo, boom. We got a match. We confirmed it graphically. But that's the idea, right? That the thing's inside the envelope, therefore it's safe. How safe? Well, here we go. It's this far from being outside the edge, so there's the safety factor graphically. And that's it. And so the dog needs to go out, so I better go run home.